Okay, I just wanted to provide a key for the measurement in scientific tools Nearpod that we did yesterday. So again, you log in with Google. It's going to ask you to connect to your account, which is, again, it's easier for you than typing. Just make sure it's you. Hit yes, and it gives me both your first and last name. Remember, I defined that if we spoken or written summary of an observation, that is a description. We're just describing what happens. And if we're interpreting those observations, explaining kind of like a why, that's an explanation. So I kind of equated this yesterday. If, as a parent, if my kid's doing something weird, I'm like, "What are you doing?" If they say, "Well, I'm running around with whipped cream on my head," that's just describing what's happening. The explanation would be why, and usually they don't have a good answer for that. So description explain what you see. Explanation tells why whatever is happening is happening. Always make sure you hit done. Confirm your responses. Move to the next one. Now here on this picture, all I wanted you to do was to include an observation and tell me whether it was a description or an explanation. Were you just telling me what you see, or are you explaining what you see? So if I have there are two men in a boat, that's a description. When I get to go things like dad and son bonding, that's not actually a description, that's an explanation. You don't know their dad and son, but you're explaining what's going on, which is different than just describing. Okay? So make sure you include a observation. I am not going to go through the entire video. We did, I guess I have to. All right, so here we go.
What does the French Revolution have to do with the time NASA accidentally crashed a $200 million orbiter into the surface of Mars? Actually, everything. That crash happened due to an error in converting between two measurement systems, U.S. customary units and their SI or metric equivalents.
So in the United States, we use what are called customary units. Those are things like feet, pounds, inches, yards, gallons. Make sure you click and you submit and then continue playing.
So what's the connection to the French Revolution? Let's explain. For the majority of recorded human history, units like the weight of a grain or the length of a hand weren't exact and varied from place to place.
So we discussed in class why this would be a problem. When you start talking about early cultures and their trading, if I have different measurements for different units, it's really hard to trade. So why would having different measurements around the world be a problem? Think of trade and exchange. The measurements would not be the same. I use the example of in early America, when you bought a horse, you usually bought it by a size of a measurement called a hand. But the problem is, whose hand? If it's my hand is smaller than the other guy's hands, whose hand do we agree upon? So having a set unit of measurements really allows us to kind of alleviate those problems. Make sure you submit your response.
And different regions didn't just use varying measurements. They had completely different number systems as well. By the late Middle Ages, the Hindu-Arabic decimal system mostly replaced Roman numerals and fractions in Europe. But efforts by scholars like John Wilkins to promote standard decimal-based measures were less successful. With 250,000 different units in France alone, any widespread change would require massive disruption. And in 1789, that disruption came.
Close my door, I'll be right back.
The leaders of the French Revolution didn't just overthrow the monarchy. They sought to completely transform society according to the rational principles of the Enlightenment. When the new government took power, the Academy of Sciences convened to reform the system of measurements. Old standards based on arbitrary authority or local traditions were replaced with mathematical and natural relationships. For example, the meter, from the Greek word for measure, was defined as 1/10,000,000th between the equator and North Pole.
So they're asking you what the meter is a measure of. A meter is a measure of actual length. We'll discuss that on Friday.
And the new metric system was, in the words of the Marquis de Condorcet, for all people, for all time. Standardizing measurements had political advantages for the revolutionaries as well. Nobles could no longer manipulate local units to extract more rent from commoners, while the government could collect taxes more efficiently. And switching to a new Republican calendar with 10-day weeks reduced reduced church power by eliminating Sundays. Adoption of this new system wasn't easy. In fact, it was a bit of a mess. At first, people used new units alongside old ones, and the Republican calendar was eventually abandoned. When Napoleon Bonaparte took power, he allowed small businesses to use traditional measurements, redefined in metric terms. But the metric system remained standard for 4 years, and it spread across the continent, along with France's borders. While Napoleon's empire lasted 8 years, its legacy endured far longer. Some European countries reverted to old measurements upon independence. Others realized the value of standardization in an age of international trade. After Portugal and the Netherlands switched to metric voluntarily, other nations followed, with colonial empires spreading the system around the world. As France's main rival, Britain had resisted revolutionary ideas and retained its traditional units. But over the next 2 centuries, the British Empire slowly transitioned, first approving the metric system as an optional alternative before gradually making it official. However, this switch came too late for 13 former colonies that had already gained independence. The United States of America stuck with the English units of its colonial past, and today remains one of only 3 countries which haven't fully embraced the metric system.
So how many countries in the United States don't use the customer units, the same system we use? Only 3 of them. We are one of only 3 countries that do the system that we use in our country.
Despite constant initiatives for metrication, many Americans consider units like feet and pounds more intuitive. And ironically, some regard the once revolutionary metric system as a symbol of global conformity. Nevertheless, the metric system is almost universally used in science and medicine, and it continues to evolve according to its original principles. For a long time, standard units were actually defined by carefully maintained physical prototypes, but thanks to improving technology and precision, these objects with limited access and unreliable longevity are now being replaced with standards based on universal constants, like the speed of light. Consistent measurements are such an integral part of our daily lives that it's hard to appreciate what a major accomplishment for humanity they've been. And just as it arose from a political revolution, the metric system remains crucial for the scientific revolutions to come.
Okay, so make sure you watch that and answer those questions. And then we talked about the difference between precision and accuracy. The description of how similar or close measurements are to each other, that is called precision. So how close my results are to each other, that's precision. But again, it's not accuracy. So if I play darts and I always miss the board by about 5 feet, completely just miss the board, but I always miss the exact same spot, I'm precise, but I'm not accurate. A description of how close a measurement is to an accepted value, that is its accuracy. So that's like whether I can hit the bullseye if that's the target I'm aiming for. Okay, and then it asks you to draw 2 yellow dots that are precise but not accurate. So you go to the tool, select yellow, and again, if I make 2 dots that are near each other, these are precise in the fact that they're close to each other, but they're not accurate because they're nowhere near the target where I want them to be. If I want 2 blue dots that are accurate and precise, those would be 2 dots together, so they're precise, but also accurate. They're towards the center of the target where I'd want them to be. And finally, 2 black dots that are neither precise nor accurate. Well, if they're not precise or they're not accurate, they're nowhere near the target. If they're not precise, they're nowhere near each other. So precise, they're together. Accurate and precise, they're together and they're where I want them to be. Neither precise nor accurate. Make sure you submit. Now I'm going to skip this one for the sake of time. You're welcome to watch this. It's about scientific notation. We won't do a lot of work with scientific notation, but I wanted to introduce you to the concept. But for the sake of time, I'm not going to have you go through it. What is the correct conversion for the diameter? 4.0 times 10 to the 4th kilometer, which is the circumference of Earth. And so what I would do is I look at the 4, and that tells me how many spaces I move my decimal point. And again, don't panic if you're not understanding this, because we will go through this in detail later on this year. So I would move it 1. So if my decimal point is here, I go 1, 2, 3, 4 spaces, that becomes 40,000. Okay. We use a science journal to record any observations, write questions or hypotheses. We'll use our Chromebooks or any data formations in the Chromebook, any sheets or things like that. If we were going to measure mass, we would use a balance. We'll talk about what mass is later in the year. Two common types of balances are the electronic balance and the triple beam balance. Triple beam balance is very similar to like when you go to the doctor's office and they take your weight and they have those 3 beams that they slide over to find out what your weight is. Though it's a very similar process, we'll talk about that next week. If we measure the volume of liquids, we could use a beaker, but a graduated cylinder is a much more accurate measure because they're smaller and they actually have a lot more lines of increments that help us to understand what the measurements are. So a graduated cylinder is always a better. A temperature, if we want to find the temperature of a substance, we will use a thermometer. We'll talk about the various kinds of those next week when we talk about temperature. The Kelvin, when we talk about temperature, the Kelvin is the SI, or the metric system unit for temperature. But in science class, we measure in degrees Celsius. So we'll talk about the difference of those next Thursday when we talk about temperature. If we want to determine whether something's an acid or a base, we would use a pH paper. If your parents have a pool or if you have an aquarium, you may have used this in the past, or a litmus paper works, or even cabbage juice. To measure the weight or amount of force applied to an object, we use a spring scale. We'll be doing that when we talk about gravity and friction. And if I'm not mistaken, that leads us to the time to climb. I'm not going to go through the time. Well, why not? So I will do the time to climb just to see if we can give you the answers. Let's go with this guy. That's fine. Make sure you hit start, not the blue arrow, or you'll skip the activity. I am casting while I'm running it, so that's probably why I'm a little slow. So be patient. A spoken or written summary of observations is called this. All of the leaves are turning colors as an example. If I'm just telling you what I'm seeing, that is a description. And you can see all the characters and how we did. Let's see. You won't tell me who. I would be able to see who was the first, but you guys can't. But still, it's pretty interesting. The system of measurement used in science class, we will use the metric system. We use the customary units in our daily lives, but in science class, we always use the metric system. A description of how close a measurement is to an accepted value, how close it is to where we want it to be, that is how accurate we are. The most accurate tool for measuring the volume of a liquid would be a graduated cylinder. We would not use our hands. The other two would measure liquids, but they're not very precise. The graduated cylinder is always the most accurate tool. Convert the following number into scientific notation. Move the decimal so it is after to the left. All right, so we want the decimal is right after the 9. So if I'm here and I count 1, 2, 3, 4, 5, 6, 7 spaces, and I'm going to the left, so that's going to be 9.3 times 10 to the 7th power. And they're the same number, they're just written differently. And you'll do it more in math class than you'll ever do it in science class, but you should be aware it does exist. And then finally, you'll see your score. Hopefully that helps you. Make sure you've submitted that. I am not first place, but that's okay. I did my best. Hopefully that explains it. Have a good day.